Okay, so in this lesson, we're going to be talking about functions and graphs, and in part one, we're going to determine if a relation is a function, and then for each relation, you're going to determine the domain and range of that relation. And so, before we get started, though, let's talk about the definition of a relation. So, a relation is a set of ordered pairs, and the set of the all first coordinates. So, in this lesson, we're going to think of these as the x-coordinate and y-coordinate. So your first coordinate in the ordered pair, remember your ordered pair. In an ordered pair, your first coordinate is x, your second coordinate is y. So for example, this was -5, 6. X is -5, y is 6. So that's what that means. Okay, so ordered pair. So, so the domain would be the set of your x-coordinates, and the range would be the set of y-coordinates. So they use the word first coordinate or component, first component, which is the x-coordinate, and then the second component here, the second component would be the y-coordinate. First component would be part of your domain, second component would be part of your range. So x-coordinate, y-coordinate. Set of x's is your domain, set of y's is the range. Okay? Now let's talk about the definition of function. Now a function is a relation, because remember, a relation is a set of ordered pairs, so you can see what a function is. But a function is a special kind of relation. A function is a correspondence from the first set, from your domain, to the range. So you're going from domain to range. That's important. Correspondence from the first set to the second set. Okay, so such that each element in the domain corresponds to exactly one element in the range. So we keep coming back to this definition. So basically, for each x-coordinate, there is assigned only one y-coordinate. Okay? All right, so let's look at number one. So in these directions, you're going to be asked, determine whether each relation is a function, then give the domain and range of each relation. All right, so we're going to look at about 5 or 6 of those. Okay, number one. So look at this one. So let's suppose we had the ordered pair 4, 5, 6, 7, and 8, 8. Now remember, this is a relation because according to our definition, a relation is a set of ordered pairs. And notice that this is a set of ordered pairs. It has 3 ordered pairs. It has 3 points. All right, so to help us determine if this relation is a function, it helps if you use a mapping in your mind, or you can write it out. So just draw something like this, and remember, if you use the x and y coordinate, the variables in this lesson will contain x and y. So let's call this the x coordinate and this the y. So remember, the set of x's here would be your domain, and the set of y's would be your range. Okay? All right, so all you do is just list your x coordinates here, list your y coordinates here, and then the correspondence. So for example, here's what you would do. You would say, well, when x is 4, it gets mapped to 5. So when x is 4, the correspondence is 5. When x is 6, it gets mapped to 7. When x is 8, it gets mapped to 8. Okay? So for each x-coordinate, look at this. For each x-coordinate, there is exactly one y-coordinate. That's the definition of a function. For each element in the domain, there corresponds exactly one element in the range. When x is 4, there's only one y value. It is 5. When x is 6, there's only one y value. It is 7. When x is 8, there's only one y value. It is 8. Notice also what helps is the arrows that are extended from it. Notice when x is 4, there's only one arrow going from it. When x is 6, there's only one arrow. When x is 8, there's only one arrow. Keep in mind also that when you do these problems, you want to make sure that if your elements are listed more than once, you list them only once. So if there were 2 4s here, you would only list it once. If there are 2 5s, only list it once. Don't list it more than once, list it only once. Okay, so by definition of a function, this relation is a function. All right, so the domain would be the set of x coordinates. So your x coordinates, and you could just get it from the mapping if you did it. And let's put it in numerical order from smallest to largest. So it'll be 4, 6, and 8. And then your range would be 5, 7, and 8. All right, so your domain consists of these three elements, and your range consists of these three elements. Now, of course, the number of elements here don't always have to match up the number of elements here. So the number of elements could be different in either case. All right, number 2. Suppose you had this mapping. This relation. 5, 6, 5, 7, 6, 6, and 6, 7. All right, so this relation consists of 4 ordered pairs. And so again, let's look at the mapping. So my domain, my range. So your x coordinates, your y coordinates. So when x is 5, it gets mapped to 6. When x is 5, now remember I already listed once. I already listed, so don't list it again. Do not list it again. List it just once. So basically you're going to say when x is 5, so you can draw an arrow coming from it. It gets mapped to 7. When x is 6, it gets mapped to 6. I already have 6 listed in my range, so already don't list it again. Do not list it again. Just extend it to that 6 that's there. And when x is 6, I already have 6 listed. Don't list it again. It gets mapped to 7. All right, so let's look at the definition of function again. Definition of function. For each x coordinate, there is assigned only one y coordinate. For each element in the domain, there corresponds exactly one element in the range. So if you look at this, when x is 5, for this element 5 that's in my domain, do I get only one y value? Is it assigned only one y value? The answer is no, because it is assigned two y values. When x is 5, I get a 6, and when x is 5, I also get a 7. So right away, and the 6 as well, but you didn't have to look at the 6 right away. This is not a function because of this 5 right here, and also the 6. But all you have to do is just look at one of them. If one of them fails, then it's not a function. So by definition of function, this relation is not a function. All right, now sometimes you're going to be asked to explain why it's not a function. So just say something like this: because, and all you have to do is give an example that makes the definition false, or that contradicts the definition, I should say. So it's not a function because when x equals 5, there are two y values. Okay, namely y equals 6, y equals 7. Okay, now the domain. Okay, so the domain of this relation, again, only lists the elements 1. Don't say 5, 5, 6, 6. Don't do that. Only list it once. List it once. So domain is 5, 6. The range, again, only listed once. The range is 6, 7. So there's number 2. All right, number 3. Number 3. Suppose we had this one. All right, suppose we had 10, 4, -2, 4, -1, 1, and 5, 6. So I have this set of ordered pairs, so I'm looking at this relation. I'm going to look at the mapping. I want to determine if this relation is a function. So I'm going to look at the mapping. So here's my domain. And then here's my range. So your set of x coordinates, your set of y coordinates. So when x is 10, it gets mapped to 4. When x is negative 2, it gets mapped to 4. When x is negative 1, it gets mapped to 1. Notice again, you only list the elements once. If it occurs more than once, list it once. So notice 4 was listed twice, it's only listed once. When x is 5, it gets mapped to 6. So is this a function or not? Well, remember the definition. For each x coordinate, there's assigned only one y coordinate. That's the definition of function. For each x coordinate, there's assigned only one y coordinate. What's going to confuse people are those two arrows that are pointing to this 4. Well, that's fine. That's okay. You can have, these right here could all be the same y value, make no difference. It's still a function. So you got to use the definition of function. The definition of function only says this. It says for each x coordinate, there's only one y coordinate. So ask yourself, when x is 10, is there only one y coordinate assigned to it? Yes, it is 4. There's no other y coordinate assigned to it. Notice I'm doing the idea of another arrow. See, there's nothing else assigned to it. There's just 1. When x is negative 2, there's only one y coordinate, 4. When x is negative 1, there's only one y coordinate, 1. When x is 5, there's only one y coordinate, 6. So by definition of function, this relation is a function. All right, and so the domain, again, only list them once. The domain would be, let's put this in numerical order. So it would be negative 2, negative 1, and then 5 and 10. And the range, remember your set of y coordinates, would be 1, 4, and 6. You can only list them once. All right, number 4. Suppose you had this relation, negative 7, negative 7, negative 5, negative 5, negative 3, negative 3, 0, 0. All right, again, let's determine this is if this is a function. So let's look at the domain. Let's look at the range. All right, when x is negative 7, it gets mapped to negative 7. So far for this x coordinate, there's only one y coordinate. So we're okay so far, but you got to check all of them. There's only one arrow extending from it so far. When x is negative 5, it gets mapped to negative 5. So far, we're good. When x is negative 5, there's only one y value so far. When x is negative 7, there's only one y value so far. When x is negative 3, it gets mapped to negative 3. And when x is 0, it gets mapped to 0. So notice, for each x coordinate, there's only one arrow extending from it. So that means for each x coordinate, there's only one y coordinate assigned to it. So by definition of function, this relation is a function. All right, and so the domain would be, and let's put these in numerical order. So the domain is your set of x coordinates. There's your set of first components, first coordinates. So negative 7, negative 5, negative 3, and 0. And the range are the same numbers. You can see they're the same numbers. Negative 7, negative 5, negative 3, and 0. All right, so that was number 4. Okay, let's look at 5. Okay, 5, you have this relation, negative 2, comma 6, negative 1, comma 6, 4, comma 6, negative 1, comma 7. All right, so do the mapping. This is your set of first components. That's your domain. And your y coordinates are the second components, second coordinates. It will be your range. So when x is negative 2, it gets mapped to 6. When x is negative 1, it gets mapped to 6. Now don't do a 6 again. If you do the 6 again, you're probably going to mess up with the definition. So use them only once. So when x is negative 1, it gets mapped to 6. When x is 4, it gets mapped to 6. When x is negative 1, don't do the negative 1 again because you already have it. It gets mapped to 7. Okay, so that's what we have. So here's my correspondence. So you got to do this correctly. So the first thing in your mind is this is what you would see. All right, now you ask yourself, is there anything in here that doesn't make it a function? So look at negative 2. When x is negative 2, do you get only one y value? The answer is yes. Look at 4. When x is 4, do you get only one y value? The answer is yes. So is this a function? The answer is no. Look at negative 1. When x is negative 1, how many y values do you have? Well, when x is negative 1, you have a 6 and you have a what? 7. So right here, you see, when x is negative 1, how many different y values? There are 2 different y values. The definition of a function says for each x coordinate, so for when x is negative 1, there's got to be only one y coordinate. You have 2 of them, a 6 and a 7. So this is not a function. So, and you got to explain why. So by definition of function, this relation is not a function because, and you got to just explain what part is not satisfying the definition. Because when x equals negative 1, there are 2 y values. Okay? Okay. All right. Let's see. Okay, so that will be the end of that part. So basically, what we wanted to do was to determine if a relation is a function, and then state the domain in range. Okay, now, still dealing with part 1. This is still part 1. Okay, still part 1. So part 1, remember the definition of a relation is a set of ordered pairs. So notice right away you can see that these are relations. 1's a relation, number 2 is a relation, number 3 is a relation, number 4 is a relation, and number 5 is a relation. And the reason you can see that is because you can see it's a set of ordered pairs. Okay, but you don't always have to have a set that looks like this for it to be a relation. All right, so for example, this graph, when you drew lines last year, y equals 2x minus 3, let's say, let's make it this. Y equals 2/3 x minus 1. When you graphed this last semester or semester before, these are relations. You were graphing relations because it's a set of ordered pairs. So remember when you did a t-table? So for example, if x is 0, you get y equals 2/3 times 0 minus 1, and 2/3 times 0 is 0, and 0 minus 1 is a negative 1. So you see the ordered pair? So then you plotted that point 0, negative 1, which is here. This is 0, negative 1. And then let's say, now remember this, if this is the coefficient of x, which is your slope. Remember, this is a slope. Y equals mx plus b. So whatever you multiply an x by is called the slope. So if your slope is a fraction, what you want to do is use numbers that are divisible by 3. So if x is 3, I get y equals 2/3 times times 3 minus 1, because I'm saying x is 3. 2 times 3 is 6, so I get 6/3 minus 1. 6/3. And 6/3 is 2, and 2 minus 1 is 1. So if you plot the point 3, 1, you get that. And you can keep on going, right? You can keep adding these things. So how many points are in this set, in this relation? Well, there's an infinite number of points. So this set here consists of an infinite number of points, whereas this set was a finite. So this is a finite set. 1, 2, 3, 4. You can count them. Here, you can't count them because you can do an infinite number of these points. You can let x be 2. You can let x be -5. You can let x be -6.7 if you wanted to. All right, and that's why, and remember, those are solutions as well. So the graph, you just connect the dots, and then this is your relation. So relation is a set of ordered pairs. And notice a graph is made up of a set of ordered pairs. See all these ordered pairs? These are all ordered pairs. So the point being this, that even though the definition says a set of ordered pairs, and you think of this, most students think of this, graphs are also a relation. So this is also a relation because it is made up of a set of ordered pairs. Okay? So that's what I wanted you to think about. All right, now, let's look at this. There is something called the vertical line test. So you can use the vertical line test to identify graphs in which, that should be in which y is a function of x. So you can use the vertical line test to identify graphs in which y is a function of x. Okay, so I'm going to go back over here. So remember this line I drew? This line right here? So I'm going to ask you this. When x is 0, remember the definition of function. When x is 0, what was my y value? The y value was -1. When x is 3, what was my y value? The y value was 1. When x is, let's say, -3, if I do this again, if x is -3, y equals 2/3 times a -3 minus 1. 2 times a -3 is a -6, so I get -6 divided by 3 minus 1. So -6 divided by 3 is a -2, and a -1 is a -3. So when x is -3, is there only one y value? 1, 2, 3, and it was -3. So right here. So -3. So again, you can't see it, but that's -3. So notice for each x coordinate, notice what I'm doing. For this x coordinate, this is 4, and look at the point here, there's only one y coordinate assigned to it. So if I put 4 here, there'll be only one y coordinate. If I put -8 here, there'll be only y coordinate. So by definition of function, for each x, there's only what? One y value. So this is a function, okay? Now, you didn't have to do all this to determine if this was a function. If I give you the graph, notice this part says, if you're given a graph, identify if it's a function. Identify if y is a function of x. So is this a function? Okay, so look at how the vertical line test looks. So you're going to draw vertical lines. That's all you're doing, drawing vertical lines. And you ask yourself, see how I drew this vertical line? When my x coordinate is this, whatever this x coordinate is right here, whatever this x coordinate is, do I get only one y value on the graph? And the answer is yes. It intersects it just once. It intersects it just once. So for this x coordinate, do I get only one y coordinate? Yes. It's right here, whatever that y coordinate is. Okay? For this x coordinate, and look at this point, is there only one y coordinate? Yes, it's just this one. Okay? So let me just say what the vertical line test says. Okay, if a vertical line intersects the graph only once everywhere, only once everywhere, then the graph represents a function. Okay, so then the graph represents a function. So notice, when I drew these vertical lines, it intersected the graph once everywhere. So that means that for each of those x coordinates, whatever these x coordinates are, there's only one y value assigned to it. Whatever that y value is, there's only one y value assigned to it. Okay? All right, so let's look at this one. Suppose you had this circle. So this is number 1, okay, number 2. All right, suppose you had this one. I'm going to draw a circle. Let's say it's Looks like this. I'm making it up, so it's not going to look very well. All right. And then I'm going to look at this. Let's say this is 3 right here. I'm making this thing up. And so when x is 3, I get this point here. Okay. And I also get this point here. You see this? So when x is 3, how many points on the graph when x is 3? There are 2 of them. So let's say this right here is 7. I'm making this up. And let's say this is negative 7. So when x is 3, this point here is 3 comma 7. And this point here is 3 comma negative 7. Okay, so now I'm asking you this. For this x coordinate, is there only one y coordinate? The answer is no. When x equals 3, there are 2 y coordinates. So this is not a function. All right, this is not a function. Now, I put these there to explain to you the vertical line test. So if I draw a vertical line through 3, notice the vertical line intersects the graph. See how it intersects the graph once here, once everywhere, right? Here, if it intersects it more than once, if it intersects the graph 2 or more times at least once, then it's not a function. So notice there are a lot of places where it intersects the graph. There's an infinite number of places where it intersects the graph more than once. Now here it intersects the graph once, right here, but everywhere else it intersects it more than once. So notice what that means is this. For this x coordinate, there are 2, see how there are 2 points? There are 2 different y coordinates. 2 different y coordinates. When x is 3, there are 2 different y coordinates. See this? There are 2 different y coordinates. So given a graph, use a vertical line test, and all you have to do is just say something like, this is not a function because it fails the vertical line test. All right, now, make sure you understand why it fails the vertical line test, because by definition of the function, for each x coordinate, there's got to be only one y coordinate. So notice when x is 3, you have how many different y coordinates? 2, because it intersects the graph twice, so that means that the y coordinates are different. See how it intersects the graph twice here, here, and here? That means that for this x coordinate here, there are 2 different y coordinates. So right away, it's not a function. All right, let's look at another one. All right, that was number 2. Let's make this number 3. I'm going to go ahead and put it on here. Okay, so again, use a vertical line test to identify graphs in which y is a function of x. All right. All right, so let's look at this one. All right, so last semester or the semester before, you drew horizontal lines. So the question is this: is this horizontal line a function? Is that y as a function of x? So is that a function? Well, use the vertical line test. Every time I draw a vertical line, it intersects the graph how many times? Once. Now what that means is that for this x coordinate, there's only one y coordinate. For this x coordinate right here, there's only one y coordinate. In fact, the y coordinates are the same because it's a horizontal line. So I want you to see this. So remember so right away, by the vertical line test, this is a function. Okay? So it defines y as a function of x. So y is a function of x. All right, now what I wanted to do though was, let's say this is 1, 2, let's say this is 3 right here. All right, so what that means is this: when x is 1, look at this, when x is 1, my y value is 3. When x is 2, my y value is, let me do the mapping. When x is 1, my y value is 3. When x is 2, my y value is 3. Is 3. When x is 3, my y value is 3. Notice, no matter what point I use, when x is negative 1, my y value is 3. When x is negative 2, my y value is 3. But this is a function because remember our discussion earlier, for each x coordinate, there's only one y coordinate. They're all 3's. There's only one for each one. All right. So by the vertical line test, this is a function. But I did want you to see this. Okay, number 4, let's suppose you had this. All right, let's suppose you had a vertical line. Now, notice that when I draw the vertical line, when I use the vertical line test, this vertical line test, it intersects the graph more than once. So it intersects the graph more than once, so that means it's not a function. So by it fails the vertical line test. All right, so it's not a function. All right, so what that means in terms of a graph, let's say this is negative 4 right here, negative 4. And this is 1, 2, 3, 4, and so on. Negative 1, negative 2, negative 3, and so on. All right, so what that means is this. When x is negative 4, I look at this point here, and my y value is 1. When x is negative 4, I can look at this y value here, and my y value is 3. So right away, notice for this x coordinate, in fact, it's always going to be true. For this, no matter, remember, these are always going to be x's. If you remember this, the vertical line, all these points have the same x coordinate. So basically, you can have all these arrows pointing away from negative 4. So automatically fails the vertical line test, because when x, according to the definition of a function, for each x coordinate, it's got to be only one y coordinate. This is not true. For x equal negative 4, you have an infinite number of y coordinates. All right, so this is not a function. Number 5. Let's suppose, let me make sure, I think we already did this one that I wanted to do, yeah. All right, let's suppose we had this. So there's, right here. So does this represent a function? Well, it intersects the graph once here, so is that a function? It intersected once, it's right here. So for this x coordinate here, there's only one y coordinate, whatever that y coordinate is. The answer is no, it's not a function, because you got to check everywhere. So notice everywhere else, it intersected what? More than once. So if it fails one time, it's not a function. So you could have stopped here when you found this one, and you saw that it intersected more than once, which means that there are two different y values. This y value and this y value, two y values. Right away, you can say it's not a function. So this is not a function, it fails the vertical line test. So it's not a function. All right. So again, based on this part's easy. So I want you to know. I just wanted you to know that for that graphs are relations, because graphs are made up of ordered pairs. These graphs here are made up of, this circle is made up of a set of ordered pairs. Okay? All right. Okay, now let's look at another one. Okay, so you could, another way to represent a relation, I'm going to have to cover this part. Another way to represent a relation is through an equation. So look, when we did this in the beginning, right here, this equation right here, see this equation? This equation represents a relation because it is a set of what? Ordered pairs. Your x and your y. It's a set of ordered pairs. And you can see the set of ordered pairs. 0, negative 1, 3, 1, negative 3, negative 3, and so on. So it's a set of ordered pairs. So an equation in x and y is a set of ordered pairs. So it's a relation. So you can represent a graph, you can represent a relation as a set of ordered pairs, a finite set. This is a finite set. You can count those. Or you can represent them as a graph, and notice this is an infinite set of ordered pairs. Or you can represent them as an equation. And so that's what the next one's going to be. So the next part says determine whether each equation defines y as a function of x. Now this is going to be a little bit more challenging for people. So listen carefully as we go to this. So determine whether each relation represents is a function, defines y as a function of x. All right, so let's look at this example. X plus y equals 6. X plus y equals 6. All right, so the idea, remember, it says defines y as a function of x. So basically, you want to get y by itself. Always get y by itself. That's what you want to do. So so you get y, so you can subtract x from both sides. So you get y equals negative x plus 6. Okay, negative x plus 6. And what you may want to do now is this. Just think about your ordered pairs. So when x is 0, I get y equals the opposite of 0 plus 6. So in place of x, I plugged in 0. And so I get 0 plus 6, which is just 6. So notice for this x coordinate, there's only one y coordinate. So far, it looks like it's a function. But do a few more. When x is 2, I get y equals the opposite of 2 plus 6, which is 4. So for this x coordinate, there's only one y coordinate. When x is, let's say, negative 1, I get y equals the opposite of x, so that's the opposite of negative 1 plus 6. The opposite of negative 1 is a positive 1 plus 6, which is 7. So notice for each x coordinate, I'm getting only one y coordinate. Now remember, there are an infinite number of coordinates here, so you can't list them all, but basically I did a positive 1, I did a negative 1, I did 0, and it looks like for each x coordinate, there's only one y coordinate. So right away, I can say this relation is a function. Or I can say y is a function of x. Okay, so y is a function of x right here. So y is a function of x. Now when you graph this, if you think about it, if you were to graph it, now we're done with this, that's all you had to do. But if you wanted to graph, look what happens. Now you don't want to graph these things because some of these equations are not easy to graph. So you want to do this idea here. But if you graph and you plot your point 0, 6, let's say 0, 6 is here. I'm making this up. I'm not scaling this right. And let's say 2, 4 is here. Let's say 2, 4 is here. And notice you get a line, right? Remember, this is a line. And remember the slope, y equals mx plus b. The slope here is a negative 1. Since the slope is negative, your line should go down. All right, and then use a vertical line test. What do you notice? No matter where I draw the vertical line, it intersects the graph just once. So therefore, it's a function. All right, number 2. Let's say you had this for number 2. Let's say you had x squared plus y equal 16. All right, so the first thing you want to do is to get y by itself. Always get y by itself. So you subtract x squared. Combine like terms. I get y equals negative x squared plus 16. Okay, so this is quadratic, and we're going to learn a little bit more about graphing these soon. But you did graph some of these last year, some easier kinds. But this is quadratic, so the graph would be a parabola. And since this is negative, it'll be going down. But you didn't have to know all this. You can just plot some points, and so that would be what you might want to do. So look carefully. When x is 0, I get y equals the opposite of 0 squared. Remember, x is 0, so 0 squared plus 16. This right here, 0 squared 0, the opposite of 0 is still 0, plus 16, which is 16. So when x is 0, my y value is 16. Again, don't just do one of them. You're going to probably mess up. Do a few more. When x is, let's say negative 2. When x is negative 2, I get y equals the opposite of negative 2 squared plus 16. And negative 2 squared is 4, so this becomes a negative 4 plus 16, which is 12. So notice for this x coordinate, I get just one y coordinate. Let's try 2. When x is 2, I get y equals the opposite of 2 squared plus 16. 2 squared is 4, but this is still a negative 4 plus 16, which is 12. All right, now I'm going to ask you this. Notice for each x coordinate, there's only one y coordinate. Don't let the fact that there are two y coordinates confuse you. Remember what we did earlier? It's okay. It is okay for the y coordinates to repeat as long as it's assigned to just one x coordinate. So the definition says this. For each x coordinate, there's just one y coordinate. So ask yourself, when x is 0, do you have just one y coordinate? Yes, it's 16. When x is negative 2, is there only one y coordinate? Yes, it is 12. When x is 2, is there only one y coordinate? Yes, it is 12. So this is a function. So y is a function of x. Okay, number 3. Suppose you had this. Suppose you had x squared plus y squared equal 16. X squared plus y squared equal 16. All right, so again, you got to get y by itself. So I'm going to subtract x squared from both sides. And you see how you have to do this algebraically? So subtract x squared from both sides. So I get y squared equal negative x squared plus 16. All right. And so then to get y by itself, I can take the square root of both sides. And when I take the square root of both sides, you do the plus or minus. So these undo each other. So I get y equals plus or minus the square root of negative x squared plus 16. All right, so that's how it looks. So you bring the x squared over. Then to get y by itself, you see right now you're squaring, the opposite is square root, but remember when you square root, you get plus or minus. And so if I do it, if I say let x be 0, I get y equals plus or minus the square root of negative 0 squared plus 16. And then remember, 0 squared is 0, the opposite of 0 is still 0, so I get plus or minus the square root of 16, which is plus or minus 4. So 4 and a negative 4. So notice, see this right here? When x is 0, I get a 4 and a what? Negative 4. So right away, I don't have to do anything else. Right away, what do you notice? Is this a function or not? Well, this is not a function. Because when x is 0, there are two different y values. Okay, so it's not a function. So y is not a function of x. Okay, now, you could have done this. I just want to remind you about this. Did any of you recognize that this is an equation of a circle? This is the equation of a circle. X squared plus y squared equals 16. That's a circle. This is a circle. So go back to the section that dealt with that. This is the equation of a circle. And so notice the center of the circle is 0, 0. Remember, x minus 0 squared plus y minus 0 squared equals 16. And the radius is 4. Square root of 16 is 4. So if you were to graph it, here's the center. You go 4 units to the right, 4 units up, 4 units to the left, 4 units down, and you get the circle. What do you notice? Well, it fails the vertical line test. Right here, it intersects the graph twice. That means for this x coordinate, there are two different y coordinates. All right, so you could have, unless it says do this algebraically, if it doesn't say anything at all about how to solve or how to determine it, then you can show the circle. You can show that this is the center, this is radius, and draw it, and then say by the vertical line test or you can say it fails the vertical line test. So it's not a function. Okay? All right, so just wanted to remind you that this is a circle. Hopefully you remembered it. All right, number 4, let's look at this. All right, suppose in number 4 we had this. We had x equal y squared. X equal y squared. All right, so remember, you got to get y by itself. So I'm going to take the square root of both sides. Now, don't make the mistake and think that's a circle. That's not a circle, okay? Because it's not that x squared plus y squared equal some number. So be careful. It's not a circle. But we do got to get y squared by itself. So I'm just going to transpose these so that y squared's on the left. And so then I'm going to take the square root of both sides. Don't forget the plus or minus. And so these undo each other. And so I get y equals plus or minus square root of x. So you see that plus or minus right here? When you get y by itself and you get that plus or minus, you know what that means? That means that no matter what I plug into x, there's going to be a positive and a negative of this, except for 0. So watch. When x is 0, I get y equals plus or minus the square root of 0, which is plus or minus 0, which is just 0. So notice when x is 0, there's only one y coordinate, but don't stop there. Never stop there. Let's do 2. When x is 2, I get y equals plus or minus the square root of 2. X is 2. So notice when x is 2, I get the square root of 2, and I get negative square root of 2. So right away, you can say this is not a function. See that plus or minus? Makes it not a function, but you got to explain it. So when x is 2, there are 2 different y values. Same thing here when we did this one. Let me go ahead and get it. When we did this one, you see that plus or minus right here? That plus or minus. So that means that when x is this value here, there are 2 different y values. When x is this value, there are 2 different y values. A positive one and a negative one. Okay? All right. Now let's look at this one. You have y equals the square root of x plus 4. That's all you have. That's what you see. So let's see if that's a function. So when x is, let's say, 0, I get y equals the square root of 0 plus 4, which is the square root of 4, which is just 2. So far, when x is 0, there's only one y value. All right, let's do another one. Let's say 2. Y equals the square root of 2 plus 4, which is the square root of 6. So when x is 2, there's only one y value. Now be careful, maybe you can't take the square root of a negative number. So now what I mean by that is this. If x is negative 2, I'm fine. I'm fine when x is negative 2. I get y equals the square root of negative 2 plus 4, which is the square root of 2. But the point being that for each x coordinate, what do you notice? There's just one y value. That's what you notice. So you can say this is a function. All right, now don't confuse that with the previous one. So remember, when we got y by itself, we had to take the square root of both sides. So y was not by itself here. See how y is by itself here? That's not what this was. This was y squared equal x. So you get y by itself. Here, y is already by itself. You do not see the plus or minus because this is just a positive square root they want you to look at. In fact, when you graph this, it will look like this. This is what the graph will look like. Now, you may remember this when you graph radicals last semester. And you can see this again soon. But notice this is a graph. This right here is negative 4. And does it pass the vertical line test? Yes. So for each x coordinate, there's just one y coordinate. Okay? All right. Now, you don't know this, but the graph for this one, just to show you, the graph for this one is this. This is the graph. The graph for this, and it makes sense because 0, 0, see 0, 0, 2. So this point here is 2 square root of 2, and this point here is 2 negative square root of 2. See this? So right away, see this right here, the vertical line test? When x is 2, there are 2 y values, square root of 2, negative square root of 2. But that's what the graph looks like for that one, for this right here. That's the graph. For this right here, that's the graph. Now, you would not have known this unless you plotted some more points. But it just to show you that this graph does, and it's a function, and you can see it from the graph that it does pass the vertical line test. So you just do a few. You do a few of these for each x coordinate. There's only one y coordinate, so you can say y equal square root of x plus 4 is a function. Okay. All right. Let's see if we need to do a few more. Okay, so we're good with this. We're almost at 50 minutes. So that's that part of the lesson. So that you should be good with the worksheets and with my math lab on this. All right, so that will take care of this lesson.